Welcome back to working through the homework 9.2 for mat220. We're on number 6 now, and this one is a limit. The expression is a rational function, but we got to decide, can we just plug in or not? Now, part A asks for the limit from the left, and our function is 3x minus 3 over x minus 3 squared. So we're trying to decide, is this blowing up to infinity or is it approaching a number? So as you approach 3 from the left, see how the top approach is 3 times 3 minus 3. It's just approaching 6, but the bottom is going to 0. Okay, so this is one of those 0 divided by 0 situations. Now, sorry, not 0 divided by 6 divided by 0. So we just have to figure out which type of infinity are we approaching. Are we approaching positive infinity or negative infinity? This is definitely one of the infinities. So the issue is that 0 down there. So when we approach 3, since we're approaching from the left, these numbers were smaller than 3. And so 3 from the left, so you actually have negative numbers inside that parenthesis, but they get squared, and so they become positive again. So we're actually approaching 0 from the right-hand side because of the squaring. Okay, so that was a little tricky there, and so you end up at positive infinity. And the online system, they actually don't want you to put the plus, they actually just want you to type infinity. All right, now that was part A. Part B, now we're going to approach from the right, and as we approach from the right, this same thing happens. Because of that squaring, we're going to approach 6, and the bottom's going to be approaching 0 from the right-hand side. It would have been positive anyway, but we square it and it's still positive. So this is also positive infinity. So this is a good example of a situation where we can say the limit actually exists at 3 because they're the same on both sides. So that's why we would say the limit is infinity. All right. On to number 7. We have, as we approach 8 from the left, right, and towards 8, this looks like something that's going to be simplified algebraically. So be careful here. We do have a division by 0, but I'm thinking it's going to simplify. So let's try it out. And so all we have to do to check that is see if you actually get 0 when you plug in 8. So 8 squared is 64. 64 minus 16 is 48. Let's double check that on our TI for a second. So we don't want to make arithmetic errors. So 8 squared minus 2 times 8 is 48, and then minus 48 is 0. Okay, so as you approach 8, you definitely get a 0 divided by 0. All right, so we're gonna factor that. Let me get back to that. So we're going to factor the top, and this can be true on either side, but I'll just leave it as from the left for the moment. So we're going to factor this, and so expect there to be an x minus 8 in there, and so what's left is got to be x plus 6, because you have to have the last come out to be negative 48, outer and inner to be negative 2x. So those cancel, you plug in your 8, and you get 8 plus 6, and so this is approaching 14. And it's approaching 14 whether you're on the left or the right, and so all of those limits are going to be 14. The fact that we're on the left of 8 was immaterial in this cancellation that we did. All right, let's keep going here. Now, this switching gears, this is about the dominating theorem. Now, they're using a term I don't think I used in the lecture video, but they call it the leading term. The leading term is what I was calling the highest power of x, so the term with the highest power of x. So the leading term is the term with the highest power of x. So that'd be negative 8x to the fifth. The coefficient goes with it. That's real important. Now, it determines what we were calling the end behavior. I didn't use the word end behavior a whole lot, but this is what happens out at the infinities. So we're talking about horizontal asymptotes. So the limit, as x approaches infinity for this leading term, or this polynomial, because this is going to govern the behavior. So the limit as you head out to infinity of negative 8x to the fifth. Well, the x to the fifth is going to blow up to infinity, but the negative 8 is going to make it negative infinity. So we would say the end behavior as we head out to positive infinity is negative infinity. Okay, now as you head out to negative infinity, so this was going to positive infinity in the previous example, but if you head to negative infinity, we get a different behavior here, because the x to the 5 is going to go to minus infinity. Minus infinity times negative infinity, negative 8 is positive infinity. So two different end behaviors for that leading term. So you got to be careful. You got to think about what's happening with the x. What sign is it headed towards? All right. Let me blow this up a little bit. So let's do another one. This one is going to have x to the 7 being your leading term. They're being a little tricky there. As you approach infinity, x to the infinity to positive infinity to the 7 is just going to be positive infinity. But negative infinity to the 7th power, because negative to an odd power takes you to a negative number, is going to take you to negative infinity. All right, this is that end behavior. Okay, let's keep going here. Now, we're going to need our calculator for a couple of these. So we have a function 8x plus 3 over 9x minus 2. F at 10, we're just going to plug in 10. So you got 8 times 10 plus 3 divided by 9 times 10 and minus 2. So it looks like 83 divided by 90 minus 2 would be 88. That doesn't look like that simplifies. Now, if you're ever unsure about whether something simplifies or not, just let your calculator do the work for you. Now, the Pearson product, it does require that you simplify your expressions. So you divide it, and you use the math frac button. You can see if there is a simpler fraction, and there's not. So 83 divided by 88. All right, now let's go on to part B. We need to plug in 100. Let's actually do it on the calculator. So 8 times 100 plus 3, that's the numerator. And then we're going to divide by 9 times 100 minus 2. Anyway, so just a little bit of arithmetic here. Let's turn on the math frac, and our answer is 803 divided by 898. All right. Now, as we head out to infinity, so that's just so 10, 100. So as we head out to infinity, we're plugging in bigger and bigger numbers, like 1,000, 1,000,000, 1,000,000,000. And so as you plug in larger and larger values, we know from the dominating theorem, the rational function expressions that we've talked about, it just heads to the coefficients in front of the largest powers of x. Now, that's when the degree is the same in the numerator and the denominator. So 8/9. All right. Let me get our next problem here. Let's see here. Whoop. Okay. So let's move on. So this is a similar one. The degree is the same in the top and the bottom again. And so we have minus 6x to the fourth and x to the fourth. So we still have to do a little bit of calculator work. Let's see. I did this already. So let me skip the. I didn't see that. They want these in terms of decimals. So let's fix that real quick. This is approximately 0.899, and they want it in the form that they asked for. So you gotta pay attention to those parentheses. I wasn't quite paying attention there. So this one is 894, and this one is approximately 0.89. Oh, sorry. Okay, I'm getting them mixed up. All right, sorry. This is 0.943, and this is 0.894, and then this is approximately 0.889. All right, and so that's what they're wanting, is the rounded to the nearest thousands as needed. So even though the fractions are a little more accurate, they were wanting those specifically. Okay, now on number 11, if you plug in -10 up to the nearest thousands, you get 0.5997, negative 5.997. If you plug in -20, you get -6.000. Now, what's interesting about that is we're already getting really close to the actual limit as you head out to minus infinity. Now, as you head out to minus infinity, because the degree in the... Oh, sorry, my calculator's in the way. Sorry, let me scroll that back for you here. So the f at -10 was -5.997. F at -20 is -6.000. Now, as you head out to negative infinity, because the degree in the top is the same as the degree in the bottom, right here, so the degree in the top is 4, degree at the bottom is 4. As you head out to negative infinity or positive infinity, it's determined by the ratio of the two coefficients. And so -6 is the answer to that one. All right. Great. And so in a similar thing, these last few have all had the same degree in the top and the bottom. So on number 12 here, so find the horizontal and vertical asymptotes. Okay, so these are two different types of questions. And although these were addressed in the lectures, I just want to make real clear how to find the horizontal and vertical asymptotes. So the horizontal asymptote, we look for the limit as x goes to plus or minus infinity, either one. If technically they could be different, but they are not usually for the examples that we look at. So as you head out to plus or minus infinity, because the degree is the same in the top and bottom, it's going to go to the ratio of the two leading coefficient terms there. So 5, 1. So this is going to head towards 5. So this tells us that we have a horizontal asymptote at y equals 5. All right, now they will actually want you to write the equation y equals 5. If you put 5 there, it'll count it wrong. Okay, now when we're talking about the vertical asymptotes, we're looking at spots where it blows up to infinity. So this is, you have to find a spot where this is has problems, and so the answer is at -3. If you approach -3 from either the right or the left, this thing blows up. So at this point we're not worrying about what kind of infinity it is approaching, but the top is approaching -15, and the bottom is approaching 0 from the right and the left. So keep that in mind. We have definitely a vertical asymptote. So we say x equals -3. That's the problem spot. All right, that's all for this video right now. It's getting a little long. I'll pick up with number 13 with the next video.